Full solution of higher mathematics for class 10 syllabus cover Board of Secondary Education Manipur. Chapter Arithmetic Progression solved and presented by Salam Megasundar Singh, lecturer to Stan Higher Secondary School Imphal. Video asida nainagadoribasi 2.2 Arithmetic Progression ki question number 20 dagina 26 phawbani. Question number 20. The sum of four numbers in AP is 48 and the product of the two extremes is 108. Find the numbers. AP da laiba number mari ki tinsinabagi false 48 ne, matai da laiba number ani ki purinabagi false asina 108 ne. Find the numbers. Number singdo AP da laiba number logadabane. From different ways magi laigani. Let the four numbers in AP be A plus D, A plus twice D, and A plus thrice D. Form a sheet icon low. Then by question, the their sum is given as 48, from which we have an equation involving A and D, which is equation 1. And the product of extreme side is first ka, last ka, first ka, 4 ka. Again, first ka, last ka, purinabagi follow to 108 ni. Sidagi equation amu A assume equation number fange, then the yari D as the equation 1 dagi D in terms of A solve toraga D gi value do akone sinjale adu D gi value sinjimota thrice D gi value sinjimana hena kudong sare chigi tamasi the thrice D gi value di 24 minus twice A ni pisale asumna we get this quadratic equation in A, from which we have to solve A and D. For that we factorize this, and from which we get A equal to 6 or A equal to 18. When A is 6, equation 1 gives D equal to 4. When A is 18, from equation 1 we get D equal to minus 4. When A equal to 6, D equal to 4, the four numbers are A value 6, D value 4 do low hiba form mari station jealousy. A value na equal 6 in jelani, D value na 4 in jelani, we get this. Simplify to over the second number singa sina han bagina 6 lere, ani subagina 10 lere, ahum subagina 14 lere, last ki duna 18 lere. Amokso D value ani pangwanina. When A is 18, A na 18 or about D value na minus 4 or the four numbers are A value kaya pangare, A value ani D value ani pangibane. When A is 18 and D is minus 4, the four numbers are mata ki tamashi de sinjalasi. Simplify taroga 18, 14, 10, 6 pange. Hence the four numbers are either 6, 10, 14, 18 or 18, 14, 10, 6 oirani. Question number 21. Find the arithmetic mean between 10 and 20 minus 5 and 5 minus 5 and 9. Apiba number anisiki marakta lebe arithmetic mean amaputu haibani. The arithmetic mean between 10 and 20 is sum of the 2 divided by 2 we get 15. And the arithmetic mean between minus 5 and 5 is sum of these two numbers divided by 2 we get 0. And the arithmetic mean between minus 5 and 9 is sum of the two numbers divided by 2, which is 2. Question number 22. Insert two arithmetic means between 2 and 11. Let x and y be the two arithmetic means between 2 and 11. Then 2x, y, and 11 are in AP, taken in this order. Therefore, 2 is the first term, 11 is the fourth term. Using n term formula, that is using an equal to a plus n minus 1 times of d, we have n da 11 pisilani, a da 2 pisilani, aduga n ki value da 4 pisilani, sidagi kone d ki value da 3 phange. D ki value 3 phange, the common difference 3 khangabadi first term da a first term. Thus the two AMs are first term 2 asida 3 tinjilu, and next term do the 2 plus 2 times of 3, that is 5 and I. Number anisigi marakta mention gada ba arithmetic mean ani to 5 amasung I ni. For Roman number 2, we have to insert 3 arithmetic means between 6 and 22. Let x, y, z be the 3 arithmetic means between 6 and 22. Then 6x, y, z and 22 are in AP. In this case, 6 is the first term, 22 is the fifth term. Using this formula, we have an is 22, first term is 6, number of term is 5, d is to be found out, from which we get d equal to 4. If we also known that a first term and d, thus the two AMs are mathaki lowly jealousy, first term the 4 plus 6 plus or 2 times of common difference plus 6 times or 3 times of common difference, that is 10, 14, 18 die. Roman number 3. For arithmetic means between 5 and 22. Let x, y, z and w be for arithmetic means between 5 and 22. Then these numbers are in AP. In that case, 20 is the last term and 5 is the first term. Using this formula, we get instead of an, we have to fill up 20. We have to put 20. Instead of a, we have to put 5. And number of term is 6. Common difference is to be found out. This is 3. Therefore, the 4 AMs are first term plus 3. Second term is 5 plus 2 times of common difference plus 5 plus 3 times of 3 plus and 5 plus 4 times of 3. That is item number 4. N arithmetic means between 1 and n square. Let x1, x2, x3 dot xn be n arithmetic means between 1 and n square. Then 1, x1, x2, x3, xn, n square are in AP. How many terms are there? N plus 2 terms. Using this formula, we have instead of an, we have to put n square, a1, and the number of terms from this 1 to n square is n plus 2. N is replaced by n plus 2, and we get this, from which we have to solve d equal to n minus 1. Common difference is known. Thus, the n AMs are first term plus common difference, second term, second AM plus 1 plus 2 times of n minus 1, 1 plus 3 times of n minus 1, so on, and last term is 1 plus n times of n minus 1. From which we have n equal n twice n minus 1 twice n minus 2, so on, n square minus n plus 1. Insert 3 arithmetic means between twice n plus 1 and twice n minus 1. Let x, y, z be 3 arithmetic means between these two numbers. Then these numbers are in AP. How many terms are there? 5 terms. Using this formula, we have an equal to twice n minus 1, and first term is twice n. Instead of a, we have to put twice n plus 1. And how many terms from this to this? 5 terms. N is replaced by 5, and solve d equal to minus half. Thus, the 3 AMs are first term plus common difference. Second AM is first term plus 2 times of common difference. And third AM is first term plus 2 times of 3. It must be 3 times of. It must be 3. It must be 3. Solving for this, we have twice n plus 1, and for this, cancelling this minus 1, we have twice n. For this, minus 3 by 2, 1 minus 3 by 2 is minus half, twice n minus half. 23. There are n arithmetic means between 4 and 64. If the ratios of the 4 mean to the ith is 7 is to 13, find n. N arithmetic mean between 4 and 64. Let d be the common difference of the AP. Then 4 AM divided by 8 AM, which is given as 7 is to 13. 4 AM is 4 first term plus 4 AM to first term do yauragadi 5 ni 5 minus 1 common difference the 8 arithmetic mean do first term bagi haurabadi mapan suba term ni, and cross multiply we get d equal to 6. Also 64 is the n plus 2 term of the AP. N plus 2 suba term ni 64. Using n formula, we have 64 plus equal to first term plus n plus 2 minus 1 into common difference d. Then n is equal to 9. 24. If a plus b plus c does not equal to 0 and these three expressions are in AP, prove that 1 by a, 1 by b, 1 by c are also in AP. These three numbers are in AP. We have to add 1 in each term. We have this and sum up we get numerator a plus b plus c in each. And dividing in each term by a common factor non-zero, that is a plus b plus c. Now to divide we get this, which are in AP. For question number 25, find the sum of the first 20 terms of the AP, 25 terms of the AP. For the Roman number 1, if first term is 1, common difference is 5 minus 1 equal to 4. Using sum to n terms formula, there is Sn equal to n by 2 times of twice a plus n minus 1 times of j. Giving their respective value, we have 7it. For Roman number 2, first term is 9, common difference is 12 minus 9, that is 3. Using Sn formula, we have S25 equal to 25 by 2 twice a is 9 plus n minus 1, n is 25 minus 1 times of 3. Solving, we have 1125. For Roman number 3, 30 terms of the AP this. First term, here first term A is 1 whole 2 by 3 whose value is 5 by 3 and D is second term minus first term which is 1 by 3. Using Sn formula, we have S30 equal to 30 by 2 times of twice A is 5 by 3 plus n is what? N is number of term is 30 minus 1, common difference is 1 by 3. Solving this, we have 195. 40 terms of this AP. Here A is 10 and common difference is 8 minus 10, that is minus 2. Sn formula, we get S40 equal to 40 by 2 twice A is 10 plus n minus 1, n is here 40. Common difference is minus 2. Solving these two numbers, we have minus 1160. Roman number 5, n terms of the AP this. Here A is thrice n and common difference D is second term minus first term, that is minus 1. Therefore Sn equal to n by 2 times with twice A is thrice n, a number of term is n, common difference is minus 1. Solving, we have this. Roman number 6, n terms of this AP. Here A is first term is 1 by 1 plus root over A, common difference is second term minus first term, whose subtraction we get root A by 1 minus A. Using Sn, we have this n by 2 twice A. A is what? 1 by 1 plus root over A plus n minus 1 times of common difference is this. Solving, we have this, which is the required sum. Question number 26, find the sum of the following series. This series. The terms in the series are in AP, therefore first term is 5, common difference is 8 minus 5, that is 3. And last term is 47, S is what? Using this term, we have A and the 47 pisalani, A the 5 pisalani, and number of terms to Tokadabani, common difference 3, from which we have n equal to 15. Therefore, S equal to n by 2 times of A plus L, where L is last term, and whose value is 47, n is 15, A is 5. Solving, we get 390, which is the required sum. Roman number 2. The terms in this series are in AP of first term is 4, common difference is 7 minus 4, that is 3. Last term AN is 49, S sum is what? Firstly, using this formula from which we have n equal to 16. Therefore, using Sn formula, that is n by 2 times of A plus last term. Giving their respective values, n is 16, A is 4, L last term is 49. Solving, we get S equal to 424, which is the required sum. Roman number 3. The terms in the series are in AP of first term is 4, common difference is 8 minus 4. Last term AN is IT, sum is what? Firstly, you have to use S and AN formula. Then we have n equal to 20. Here also S is the n by 2 times of A plus L, giving respective value, and solving we get required sum is 840. Find the sum of the following series. Roman number 4. Here these terms are in AFP. First term is this common difference. The second term minus first term we get minus 1. Last term an is root over 2 minus 14. S is what? Again we have to use an formula for finding number of terms. N is 16. Therefore required sum is n by 2 times of a plus n, giving respective value, and solve to find out the sum of this series. Clearly the series in AP of first term is x minus y whole square. Common difference is second term minus first term we get twice xy. Last term is an is this. S is what? Using an formula we have an is x square plus y square plus 18xy, and a first term is x minus y whole square plus n minus 1 times of common difference, that is twice xy, from which we have to solve n, that is 11. Also s equal to n by 2 times of a plus n, giving their respective values. N is what? 11. First term is x minus y whole square, and last term is x square plus y square plus 18xy. Simplifying we get 11 times of x square plus y square plus 8xy.